Hello, in this video we'll study permutation and combination. So let's first understand what is factorial of number. For example, we have 3 factorial. So this is the notation of factorial. 3 factorial is nothing but multiplication of all the numbers from all the natural numbers from 1 to 3. So this comes out to be 6. If I write 4 factorial, so this is nothing but multiplication of all the natural numbers from 1 to 4. So this will be 24. Similarly, 5 factorial will be multiplication of all the natural numbers from 1 to 5. This is 120. Similarly, we can find 7 factorial, 8 factorial and so on. 7 factorial will come out to be 15040. So this was factorial. Now let's study what is permutation. Definition of permutation and combination. So permutation is basically arrangements. It is an ordered arrangement. Ordered arrangements of objects. Okay, objects will be given, numbers are given, let's say people are given. So what you have to do, you just have to arrange them and then count. Permutation is ordered arrangement, whereas combination is nothing but selection of an object, selection of number of objects. And in selection, order will not be important. Order is not important. For example, in permutation, we will treat arrangement AB and BA as two different arrangements, whereas in combination or selection, we treat AB and BA. Both we treat it as same, that is, both are one single selection, whereas permutation, both of them are different. So here we count this as 2, but here in this we will count it as only 1. Now let's see how we arrange numbers, letters and people. For example, if I ask you, can you tell how many 3-digit numbers can you form from the number 2, 3 and 4? How many 3-digit number will be formed? So you can either write all the numbers and then count, or use the techniques of permutation and combination. So here we are basically we have to arrange all the 3 numbers 2, 3 and 4. So we have to arrange 3 numbers, so make 3 places, right? Now for this place, which numbers you can place at the first place? You can write 2, you can write 3, you can write 4, any of the 3 numbers. So can we say that we have 3 choices for the first place, right? Now since in the question repetition of the numbers are not allowed, so for example I have placed 4 at the first place. Now can I repeat 4 at the second place also? No. So how many choices you have for the second place? Now we can place either 2 or 3. So we have 2 choices for this. Let's say 2 have been placed here. Now what about this third place? How many choices we have? Only one. We can only place 3 here since 4 and 2 have been already placed. So we have only one choices at the first place. Now multiply all the possibilities. 2 in 3 to 1. This is nothing but 3 factorial, and which is 6. So how many 3-digit number will be formed from these 3 digits? 3 numbers? 6. Okay, that is nothing but 3 factorial. Now let's take 5, 8, 6 and 4. How many 4-digit number will be formed here? We have to make 4-digit number. So make the 4 places. Again go choices wise. How many choices we have at the first place? Which numbers we can put? Do we have any restriction on the first place? No. So we can place any of the 4 numbers. So we have 4 choices for this. Let's suppose that you have placed 5 at the first. You can place any of them at the first place. So consider 5 we have placed at the first place. Now how many numbers are remaining? 3. So how many choices you have at this place? Since a repetition is not allowed, we have only 3 choices. So 3. For example, consider we have put 6 here. Now how many numbers are remaining? 4 and 8. So we have 2 choices for this and 1 choices for this. So how many numbers can be formed? Multiply all the possibilities. So which comes out to be 4 factorial is 24. Understood? So we had 3 numbers in this. So in how many ways we can place them, arrange them? 3 factorial ways. Here we had 4 numbers, so we placed in 4 factorial ways. Similarly, if I have 5 numbers, 5 digits, let's say 1, 2, 9, 8 and 7. How many 5-digit numbers can be formed? Then we can place or we can form 5 factorial numbers total using the digits 1, 2, 9, 8, 7. Obviously here we are doing that numbers are not repeating. So can we say that if we have n objects and we have to arrange all the n objects, then we can do it in how many ways? N factorial ways. Right. Now if we have 7 objects or 7 people, in how many ways you can arrange the 7 people in a row? We can arrange them in 7 factorial ways. For example, you have 4 letters E, F, X and Y. Now if I ask you in how many ways you can arrange all the 4 letters? So there are 4 letters, so you can arrange it in 4 factorial ways. Since there are 4 letters and we have to arrange all the 4 letters, so that can be done in 4 factorial ways. So here in these all these examples we did not have any restriction. Now if I put restriction, let's say take three digits 2, 3 and 4, earlier example. Okay, now you have to make 3-digit numbers. So how many 3-digit numbers you can form? Easy, 3 factorial numbers. 3 factorial, that is you can make 6 3-digit numbers from this. Did I put any restriction? No. Only restriction was repetition is not allowed. Now if I say how many 3-digit odd numbers can you form from these? So what you will do? Now we want odd number. It means at unit place what you will place? Only 3 we can place at the unit place. We have a restriction as at this place. So how many choices you have at the unit place? Only one choices we have. We can only put 3. Now at the first place, do we have any restriction? No, we can put any of the 2 or 4. So we have 2 choices at this place. Let's say we have put 4 at the first place. Now which number is remaining? 2. So for this we have only one choices. Multiply all the possibilities, 2 into 1 into 1, which is nothing but 2. So how many 3-digit odd numbers we can make using 2, 3 and 4? Only 2. Can we name it? Can we say 23 and 43? Only these two, right? Now next question is in how many letters basically you can form, how many words you can form from the letters of the word. Suppose Monday, how many words you can form? So there are 6 letters in the Monday. So we can form how many words? 6 factorial words from this. Did we had any restriction on this? No, we did not have any restriction. Now if I say how many 6 letter words you can form from the letters of the word Monday such that it always starts with M. All the letters should start with M. So what we will do? Do we have any restriction on the first place? Yes, now we have the restriction. What is the restriction? It is first place will always have M, right? So how many choices you have for the first place? Only one choices, that is M. Can you put O here and here? No, none of the letters, only M. So we have only one choices at this. So we have placed M. Now how many letters are remaining? Five letters are remaining. How many places we have to fill? Five places. Five letters can be placed in five places in how many ways? Can we say 5 factorial? Yes. So 1 into 5 factorial. 1 into 5 factorial, which is 5 factorial is 120. Okay. Now if you don't want to write 5 factorial, then how we will do? See. Now we have already placed M. At this place, how many choices do you have? Can you place M? No, it has already been placed. Now we can place any of the O, N, D, E, Y. So we have five choices for this. Then for this place, how many choices? Suppose we have put N here. Now how many choices? 1, 2, 3, and 4. So for this you have 4 choices. Similarly 3, 2, 1. And what is this? This is nothing but 5 factorial. So multiply all of them, you will get 120. So we can form 120 words from the letters of the word Monday such that it will always start with M. Let's take the last example and then we will stop. Last example is that consider the same word Monday, and if I ask you in how many ways you can arrange the letters of the word Monday, 6 letters, so 6 places, such that the word should always starts with M. It will always start with M and it should not end with N. Here I don't want N here, right? N should not come here, and here there will be always M. So how many words can be formed like this? So what we will do, right? Now in this case question we have two restriction at the first place as well as last place. What is the restriction at the first place? That we have to put only M here. So how many choices we have at this place? Only one choices. Now we have restriction here also. Can you place M here? No. Why? Because we have already placed an M at first place. So M is gone. Can you place N here? No. So N is already also gone. So how many choices you have for the last place? 1, 2, 3, and 4. So we have 4 choices. For example, we have put Y at the last place. So M at the first place, Y at the last place. Two letters are already placed. We have arranged two letters. Now how many places are remaining? 4 places are remaining. And how many letters we have? 4 letters. So what you can do? We can arrange 4 letters in 4 factorial ways. So total what are the number of arrangement? 1 into 4 factorial into 4. So 24 into 4 is 96. So we can make 96 letters which will have M at the first place and it will not end with N. Okay, one last question. And for example, you have A, E, R, M, and P. There are 5 letters A, E, R, M, P. How many 3 letter words you can form? 3 letter words. Okay. So what we will do? Again, we do not have any restriction. The only restriction is that we cannot repeat the letters. So at first place, how many choices you have? Which letters you can put at the first place? Any of the 5 letters we can put. We do not have any restriction. So first place is, you can arrange in 5 ways. Any of the 5 letters. Okay, now let's say we have arranged E at the first place. Now how many choices do you have at the second place? So we can place any of the A, R, M, P. So we have four choices for this. Let's say we have placed M. Now how many choices you have at the last place? Three choices. A is remaining, R is remaining, and P. So we can place any of the three. So total how many letters words you can form? 5 into 4 into 3. That is nothing but 60. So we can make 63 letter words from these words. So this was basically about the permutation, that is arrangements of objects. Okay, we'll stop. Bye bye.